Well, it's past 3:30, so we'll start. I want to welcome to the Engineering Colloquium the 83rd anniversary. What is this? Our speaker today. Actually, where's that book? This. Our speaker today is the author of the book, The Electric Sky. And now, as I was getting my doctorate in the double E electrical engineering department, I was required and asked to teach courses, and I taught laboratory courses in plasma physics, the Langmuir probe, the biolin, all that stuff, electrical engineering. And so a student of mine from many years ago contacted me and said, I've been reading this book and looking at this information about plasma, universe, and so on. What do you think of it? And he sent me a copy of the book, and it was very intriguing, and I really enjoyed it. And I'm lucky enough that we now have the author of the book, Dr. Donald Scott, here today to talk about his research. Now, I'll give you first his background, then a little interesting information aside. He earned his bachelor's and master's degrees in electrical engineering at the University of Connecticut in Storrs. Following graduation, he worked for General Electric in Schenectady on the large steam turbine generators, in Pittsfield, Massachusetts, on lightning arresters. He earned the doctorate in electrical engineering at Worcester Polytech Institute and was a member of the faculty of the Department of Electrical and Computer Engineering at the University of Massachusetts in Amherst from 1959 until his retirement in 1998. During that time, he was a recipient of several teaching awards and was, at various times, assistant department head, director of the undergraduate program, graduate admissions coordinator, and the director of the college engineering video instructional program. In 1987, the McGraw-Hill Book Company published his 730-page textbook, An Introduction to Circuit Analysis, A Systems Approach. He has authored numerous scientific papers and chapters, including 2 that will be published by the IEEE shortly. So, he is a true electrical engineering professor who writes textbooks, enjoys the fact that he can write the material into textbooks, and really gets hassled by the fact he has to come up with the questions that the students have to answer, and the answers and all that. That's the hard part of the textbook. So in 1998, when he retired, he moved out to Arizona and finally got a chance to really get into the hobby he always loved, which was telescopes, cosmology, looking at the universe and stuff. Set up his own observatory. And the more he got into it now with sky and telescope and the seriousness of it all, the more he got a little frustrated with some of the explanations and the theories and what was coming out and all the mathematics that was used to justify theories and such. And so with his background in plasma physics and his knowledge there, one thing led to another, and now he's written a book and he has a website, and I'll let him tell you the rest of this fascinating information. Dr. Scott. So I can say, so those of you that are thinking of retirement may not necessarily be that easy.
That's true. I wonder if Hello, 1, 2, yes, okay. Electrical engineering professors are very hard on the equipment sometimes. Well, thank you very much, Dan, and thank you all for inviting me here today. It's a great. Are you hearing me okay? I'm hearing an echo. I see some yeses and some nos. What is too loud, too soft, too echoey? What's your? Yeah. Let me switch off one. How's that? Okay, good. Okay. Well, again, thank you so much. Just before we get started, if you do me a favor, just so I know to whom I'm speaking, could we have a show of hands? How many people here consider themselves, let's say their professional background, their training, and so on, to be on the side of astronomy, astrophysics, cosmology, that sort of thing? Okay, good show. Okay. Are the rest of you engineers of some type? Okay. And in general physics, I'll lump you in with whichever group you want to join. Okay, thanks very much. Well, it's, as I say, it's an honor for me to be here because today, I don't know how many of you realize it, but today is the 83rd anniversary of Robert Goddard's first liquid-fueled rocket flight. He did it from a farm in Auburn, Massachusetts, my home state. The rocket was named Nell. It was 10 feet long or high. The flight was successful. As I say, it reached a maximum velocity of 60 miles an hour. It got to a maximum altitude of 41 feet, and the flight time was 2.5 seconds. Not a very auspicious start. But when you realize that was 1926, and that we walked on the moon in 69, that's not bad. So congratulations to the Goddard family on its 83rd anniversary. The title of my little talk here this afternoon is, as you see it, I hope it doesn't lead a false impression in your mind that I have the answers to everything. Clearly, that's not the case. Plasma science and engineering doesn't have the answers to everything. What I do submit is that the observations that have been made in plasma, real earthbound plasma laboratories from experiments that have been made do have a great deal to contribute to astrophysics, if the astrophysicists are willing to listen, and I hope they are. And that's one of my pleas here this afternoon. The experiments that we've done in plasma laboratories have been fairly recent, but they have been in the deep, dark past as well. And so I would claim that the first plasma scientist is Ben Franklin. He's the first guy who actually inserted a probe into a plasma. Now, the probe was a kite, and the plasma was the atmosphere in a lightning storm. But that's what he was doing. And after he survived the experiment, and we don't know how, but he did, he concluded, he was heard to remark, perhaps as he was lying on his back, I don't know, that the sky obviously was electric. Now, this was in 1750-something. And clearly his conception of what was electric was very, very primitive. The electron wasn't even going to be discovered until J.J. Thomson did it or proposed it in, what was it, 1898 or something like that. So there was a great hiatus there. What went on in that, about 100-year period? Well, what went on after Ben Franklin was all of the experimental work that laid the foundation for electrical engineering and electrical technology. We had people like Volta, Ampere, Ohm, Weber, Gauss, and so on. But what they contributed was a bunch of diverse, disparate experiments, observations, if you will. And, you know, the three-legged stool of science, observation, theory, and experiment, testing. That was the observation, but there was no theory. Then along came James Clerk Maxwell, and it was able to put all those observations together, and with the help of a fellow whose name was Oliver Heaviside, and also with the addition of a little help from Hendrik Lorentz, he came out with 4 or 5 very compact vector calculus expressions, which pretty much tell everything that you need to know about electrical and electromagnetic theory. So there was the theory. After him, at least in the realm of plasma cosmology, came a man called Christian Birkeland. Birkeland was the first person to suggest that the causation of the aurora borealis was by particles from the sun, electric current from the sun. He was severely laughed at by people like Sidney Chapman of Chapman-Vestine theory. Remember, you know, Ferraro cavity and that sort of thing. Chapman's idea was that the aurora was caused totally internally to the Earth by tidal fluctuations somehow in the ionosphere. There couldn't be